Hello everyone, welcome back to my channel. Today we have this Fujitsu power supply which does not work. The model of this power supply is DPS-250AB-99A. So let's try it first and see if we can fix it. Okay, let's first try it with my test box. Okay, we have 243 volts. Okay, the lamp flashes, which is a good sign. That means the primary side is working. Let's check the green wire. The green wire has nothing at all. So I think this power supply is missing the standby voltage. That's why it is not working. So here is the green wire and we don't have any voltage there. It's the second wire on this connector. And as you can see, we have nothing at all. So let's take it apart and check the standby voltage section. Okay, so the power supply is opened and we have two ports. One is this side, the other is this side. So the mains comes from here into this port. The big capacitor is here, and then the 340 volts is fed from this board into this board through this cable, I think. Yeah, into these connectors here. Here we have 192 volts. Yeah, so we do have voltage there. We need to discharge it. And now if we measure again, we have only 5 volts and we can discharge that using a tweezer. Okay, now we have nothing. That means the primary side is good, the capacitor is good, it's holding charge, but we have a problem with the standby voltage rail, which is not working. So let's take this board out. I think the standby voltage would be on this board. Okay, as you can see, we have a connector here. We can isolate this part from this part by disconnecting this connector. Okay, like so. And also we can take the fan, I think. Okay, so now we have this board alone. Okay, so the standby voltage IC is this one. Okay, the standby voltage IC is this one, and this is the transformer. This IC is switching. This is the main SMPS transformer, and these are the switching transistors. And here is the rectifier diode for this part. I think these two diodes are the rectifier diodes for the standby voltage. Let me take this plastic sheet. I want to test this resistor because I think this resistor is what provides the power to the standby IC. So let's check that resistor. If it is blown, then that IC is shorted. Yeah, it's 3.6 mega ohms, so it is not good. It should be 2.2 ohms or 0.22 ohms because we have red, then gold and gold stripes. So it should be 0.22 ohms resistor. That means this IC is shorted, I think, because if we trace this resistor from the other side, it's this one. It's going from here directly to the transformer, the standby transformer, and from the transformer straight away from the other pin of the transformer to the IC, this IC. So let me zoom out a little bit. So if I go from here to the transformer here, and then from here to here, as you can see, it is going to this IC. And if I do it from here to here, as you can see, it is going to the IC. So if we check the IC is shorted, 10 ohms. As you can see, drain to source, we have 10 ohms only. It's either because of the winding of the transformer or it is because of the IC. I will take the IC out And I will measure again out of the circuit, and also I will take the resistor. The IC number is TNY288PG. I hope it is visible. And there is the resistor. Okay, so let me take the IC and the resistor. Okay, so here is the IC. The IC is out. Let me clean the holes. Okay, let's check the IC now outside of the circuit. So if we check drain to source, and yeah, we have 10 ohms. So that's why that resistor is blown. It's not completely blown, but its resistance is so high. It should be 0.22 and it is reading 3 mega ohms or so. So let me take that resistor. Okay, so here is the resistor. If we check here now, we have open circuit from drain to source. So the transformer should not cause a misreading here when the IC is installed. So if you see a short here, it's directly the IC. If we test this resistor, it's actually open circuit. It does not read anything. So we need this IC and we need a resistor. Let me find them and I will come back. Okay, so here is a replacement IC and a resistor. Let's check the resistance of this resistor. I think it's 2.2, it's not 0.22. Let me measure this one. Yeah, 2.2 ohms. This one is completely open. And if we measure the new IC, drain to source, in diode mode, as you can see, it's not shorted. If I flip the probes, it reads 0.4. This one reads 10 ohms, and in diode mode, it reads short. Okay, so let's replace the resistor and the diode. This resistor is a little bit higher in wattage. I think this one is 1 watt, and this one is a quarter watt, but I think it will be okay. Okay, so the resistor and the IC is installed. Let me put it back together and we will try it. Okay, let's try it like that before installing it all together. The lamp flashed, which is a good sign. Again, the primary side is good. And if we test now from black to the green wire, we should see some voltage. And yeah, we have 11.3 volts. If I put this to the yellow wires, also we have 11.3. So this power supply is now working. Okay, let's put it here and short the green and black wires. And as you can see, it is turning on. Let me go to 200 watts. Okay, so now it's working. The fan is spinning and we have 12.1 volts. Okay. The fan stopped. We have nothing here. If I short again black to green, the fan spins and we have 12.1 volts. So it is working now. So this power supply is now fixed. I have another one, exactly the same model. I will do it in another video. Okay? So thank you for watching. I hope you enjoyed this repair. If you do, please don't forget to like, share and subscribe to my channel. Thank you so much. See you.